Think about what happens when a language model writes a line of poetry. For years, we assumed it just guessed one word at a time, with no plan at all. Then Anthropic cracked a real model open and found something stranger. It had already chosen the rhyming word for the end of the line and was steering the sentence backward to reach it. How on earth do you see that? With a technique called attribution graphs. It traces how interpretable features flow through the model's computation, turning a black box into something you can actually read. Let's walk through how it works. So how do you turn a tangle of billions of numbers into a picture you can follow? Anthropic's approach, shown in their 2025 Biology of a Large Language Model work, runs in 4 moves. Start with the model's raw activations, which on their own are a dense, uninterpretable mess. Researchers train a helper network, a sparse autoencoder or cross-layer transcoder, to rewrite those activations as a big dictionary of interpretable features. In the production Claude they studied, that replacement model held on the order of 30 million features, each one standing for a recognizable concept. Once those features exist, the method builds a causal graph for a single prompt. Every node is a feature that's switched on, and every edge shows how strongly one feature pushed the next. This wiring diagram is the attribution graph itself, mapping that exact computation from the input tokens all the way to the predicted output. Here the real work begins. You follow the edges, feature to feature, watching influence propagate across the layers. Anthropic even intervenes, clamping a feature on or off to confirm it truly causes the downstream effect, rather than merely correlating with it. That test separates a genuine mechanism from a coincidence, which is the whole reason this counts as causal. Read the finished graph, and the model's hidden reasoning shows up as legible steps. In their study, the team watched multi-step reasoning chain together, planning ahead when composing rhyming poems, and shared multilingual features that fire for a concept, no matter the language. Steps that were invisible in the raw weights become a story you can follow. So, is this just the same as reading the model's chain of thought text? Not even close. Here's the contrast. Ask a model to explain itself, and you get a plausible-sounding story, but nothing guarantees it matches the real computation. The model can confabulate, describing a tidy reasoning path it never actually took. You're trusting its words, with no way to check them against what genuinely happened inside the network. Attribution graphs work from the mechanism instead. They read the actual features and connections the model used, so the explanation is grounded in its internal wiring rather than its output text. That lets researchers catch when a model reaches the right answer for the wrong reason, and debug the failure right at its source. Strip it back, and 3 things make attribution graphs a genuine breakthrough. The building block is the interpretable feature. Sparse autoencoders and cross-layer transcoders decompose messy activations into concept a human can actually name, and that is what makes any of the downstream tracing readable in the first place. It is genuinely causal, not just descriptive. By clamping features on and off and watching the output move, researchers verify that a pathway really drives the behavior, rather than reading tea leaves in a correlation that might mean nothing. It runs on a real production model. Anthropic applied this to Claude 3.5 Haiku, not a toy network, and surface planning, multi-step reasoning, and multilingual concepts, proving the method scales to the kind of models people actually use. All right, let's lock in the essentials. Attribution graphs are an interpretability method that traces how interpretable features flow through a model's computation, exposing the internal steps behind a single output. They start by decomposing raw activations into features with sparse autoencoders or cross-layer transcoders, then wiring those features into a causal graph for one prompt. Because you can clamp features and watch the effect, the graph gives causal evidence, not just a plausible story the model happens to tell about itself. Anthropic demonstrated this on the production model Claude 3.5 Haiku, revealing poem planning and shared multilingual features. Want more AI research made clear without the hype? Come explore it with us over at standarity.com.